All right. Hello, everybody. Thank you so much for joining us for this quick update based on breaking news that's been happening over the past few weeks, which we're about to jump into. So with that, let's talk a little bit about what's going on in the news around AI, and then we'll get into specifically what we're starting to see as it relates to self-learning, self-improving AI. This is the latest breaking news element. So first and foremost, when we look at trends specifically around news and on the internet overall, we are seeing a spike. And in fact, this month is highly likely to be the highest amount of interest on the internet related to artificial intelligence that we've seen at least since 2004. So general interest is going up. The amount of news coverage is going up. The number of people that are trying to learn about AI are all going up. But when we start to dissect that out and find out what's happening behind the scenes, what news elements are really worthy to bring to your attention right now, and what may make a difference over the next few years within your organizations overall. And that specifically is around the latest and greatest on artificial intelligence. Now, with that, let me show you just a little bit about where we've been and why this is a big deal. One, all of the AIs that we're dealing with right now, for the most part, if you go back a couple of years, you'll see these are fairly static systems. In fact, the earliest systems not only were static once they were trained, they were brought online, but they couldn't search the internet or anything else. They couldn't even pull in more data overall. So they were static, sort of frozen in time systems that we used until the next system was created and allowed us to improve from the earlier version. So with all of that being said, up to this point in time, all of the AI systems overall are not necessarily learning systems the way we would consider them to be learning systems in real time. They're frozen in time pieces of these AIs are frozen in time, and we have to try and do the best we can with fine-tuning them potentially in between versions that are released. So there is no what we call meta learning actually going on at this point in time, meaning learning to learn. That's not necessarily happening in the AI community so far. So we are still confined by what humans can do with these systems overall. They're difficult to update, right? Which we've talked about. They're difficult to train. It's expensive to train. We're likely to see our first billion-dollar model cost-wise to be trained here soon. There's data limitations. A lot of people talk about the data wall. We've already consumed most of the data that's ever been created, certainly in the history of the world. And so it's harder and harder to get the models to improve without more and more data, hence the need for synthetic data and other elements to try and improve the models in the current state we have them today. Accuracy rates are continuing to become a challenge. Like, what is the accuracy of the system overall? And can we improve the accuracy of those systems? And the last one is error repetition. When you have a frozen in time model that you're going to use for the next few months, next 6 months potentially, what you're likely to see is an error on a certain day is likely to be repeated over and over and over again. You can't necessarily retrain the model in order to get those errors out of the system until you get to the next big version. And so errors can continue to propagate for a period of time. Now here's where we're trying to solve all of those problems, and I'll get to the news over the past 3 weeks or so. So the challenge is, the question on the table is, can we get these AI systems, and this is what a lot of people are working on right now, can we get the AI systems overall to start self-learning, self-improving? And in fact, in some of the documentation, it's provably improve itself. Meaning there's an empirical element to this. How do I know it made itself better? I'll cover all of this in just a few moments. But can an AI system actually train itself? Can it self-train? Can it continuously learn day after day after day after day, or minute after minute after minute after minute, based on the requirements that we set? Can a system overall self-adapt or edit or modify? Can it self-accelerate, meaning it's getting better faster and faster and faster, it's becoming more and more efficient? And ultimately, is that necessarily still going to mean we have human value alignment with the system? That's one of the big questions ethically when we start talking about self-learning AI. Is it still aligned with human values, or how do we manage that process, which we're going to talk about at the very end of our session here? How do we manage that to ensure that we are ethically using these systems and they are aligned with human values and not necessarily moving beyond what we want them to do? given the fact that most of these systems are starting to outperform most humans. So we have a system that's outperforming most humans that we have to manage and is able to self-learn, as you're going to see here in the next few moments. So some challenges for us to start thinking about. Now? Why have this call today? Why have this update? Here's what we've been seeing behind the scenes. Since April, you can see there's 10 different elements for us, in this case, that have come out, research documents specifically, or press releases about systems, the foundation models, and others that are creating self-learning models. At least they're testing and researching self-learning models. And really, when you look at the dates down that list, you'll see the vast majority of these are in the last 3 weeks. When you see these technological shifts, they have a tendency to come in waves, they come in groups. A lot of people are starting to think or work on these things. Because of that, you'll see periods of stagnation, really, where we're not really moving the needle forward very fast. And then all of a sudden, there's a big shift in the environment, and we have to ask ourselves what that means. In fact, even Sam Altman and others over at OpenAI have talked about the ability to manage the shifts is actually becoming more and more valuable for those organizations. Hence, all of you on the call or on the meeting today, being able to go through this and help manage going forward is incredibly valuable and incredibly important, not just to you, your organizations, but everybody around you overall, as this news starts to break bigger and bigger. Now, as you look down that entire list, the one I want to point out to you quickly is the MIT SEAL report. That's a bit of the one we're going to focus on today, and that's because that's created the most chatter in the background right now in the tech sector about what in the world does that just mean. You're starting to see this information start to creep out in mass media, although it's quite slow right now. I think you're going to see it more and more over the next few days as to what this means. The last one there is a rumored element of OpenAI. It's called Alice. They're working on a self-learning AI as well. That's social media reported, not confirmed within the organization overall yet. But it wouldn't surprise me, based on everybody else working on this and the last 3 weeks of announcements, that we're going to see a few more announcements related to self-learning AI. Now, when I have this conversation with a lot of people, I immediately get a reaction. Wait a minute, Hart, you're telling me this system can learn and can learn faster than I can? In theory, the answer to that is yes. Now, the reaction I get is quite significant overall, and the reaction that you're going to get is probably quite significant overall. Some of you may be having that reaction right now as well. Meaning, what does that mean? What does that mean to me? What does that mean to my business? What does that mean to society? What is this going to potentially look like? And that process of asking yourself these questions, and you're going to see it as it hits mass media, the process of asking yourself those questions and getting concerned about the potential answers if you don't have them, we generally refer to as the Frankenstein effect. So the reality of all of this as it relates to technology, AI, and others, we can go back to this concept of Frankenstein. And actually it goes much further back than that as well, but we call it the Frankenstein effect, meaning have we created something that over a period of time we're not going to be able to control anymore? And if that's the case, does that cause me concern? And if that's the case, is there a creator responsibility of this to make sure that they can control this overall? We talk about all of this as the Frankenstein effect and the creator responsibility. As these systems start learning faster and faster and faster, are we going to be able to manage those and keep those aligned with human values? I'm going to show you some schematics to give you an idea of how that's going to look and what that means for us and our businesses. How are we going to actually use this to our benefit within our own organizations as well? So as I mentioned, we're going to focus on the MIT SEAL report that was just released a few days ago. SEAL in their context stands for self-adapting LLMs. Now, they created a mechanism. It was tested. This is an R&D type of situation. So they're small models that they're testing this on to prove that in fact can occur. They did prove that they can get some pretty significant uplift based on the system that they're using now. The underlying premise is that most LLMs today that are in use are not optimally formatted. Now, we can all probably put our heads around this and say, well, the data is not that great. It's not really formatted the best. The LLMs don't necessarily have the best weighting factors, but they're still getting really good results, really interesting results. But they're not necessarily optimally formatted, which gives us an opportunity to say, okay, we can do better. The next question they asked was, can we actually produce what they call self-edits? And I'll show you what that means in just a minute. I'm going to show you a graph. We're going to walk through this. But produce self-edits. In fact, what this really means is it's replicating itself over and over and over again and testing based on specific criteria. Now, it's doing two different things, and they found that in this case, there was more value in one than the other. The first thing they were doing is changing the data within the underlying model. So data augmentation. That's an interesting element for us to consider as we go forward and when I show you what this looks like. The second one was optimization of hyperparameters. So when they're replicating themselves over and over and over again, it's changing the hyperparameters, or it's trying to optimize, and it's changing the data set. And then it's asking itself a bunch of questions to see which one performs the best. So with that, let's take a look quickly at how this can be seen visually. So I have an AI model. Here it is in the white box. It is an AI agent, it's an AI model, it is based on an LLM format. I'm going to ask it to replicate itself multiple times. And each time, change its parameters and change the data. In this case, I'm going to ask it to multiply or create 5 different versions of itself. So hence you can see the 5 boxes here. Now, once it goes through and creates those 5, in certain cases we're calling them parent and children, we're calling them different elements of this. Once it creates 5 different versions of itself, then I need to try and figure out how I'm going to look at these systems and evaluate which one of those 5 or 6, if the parent is still included, which one of those is actually the best performing model. And so what we have are question and answer pairs. We select questions, we ask those questions to each one of the models, we get the answers to those models, but those answers, we already know what the real answer should be. So we're able to evaluate, is the real answer correct or not? And so as you go through this evaluation process, it becomes really interesting to start asking yourself the question, who is or what is the evaluator? Now, can it be a human? And the answer is, it can be, yes. But now what you're trying to go through is, it's almost like the eye test for AIs. Is number 1 or number 2 better? Number 1 or number 2? Number 1 or number 2? Number 1 or number 2? As these things get faster and faster and faster, it becomes really difficult for a human to actually be in the evaluation process at this stage. So then the next question is it another AI? And that is part of some of the models that we're seeing right now, is we'll use a different AI as the evaluator overall. The third option is, do you let the AI, this model that I'm dealing with right now, evaluate itself? That is also an option that is part of one of the models that's out there that I referenced on the slides before. So is it self-referencing and self-improving, or is it leveraging a second AI to actually evaluate it to decide which one is best? So then it decides, it gets the answers to all of those. We do question and answer pairs, and we decide which one is the best model, which one performs the best on an accuracy go-forward basis. And then we say, okay, let's use that one. We are going to replace that parent necessarily, in this case, with this, call it the child, the second version of the model. But it doesn't end there, because we're not going to just do this once. In some of the models, we're doing it 80 times. We might be doing it 5 times, we might be doing 15 times, we might be doing it 20 times. Each iteration we go through is likely to become more accurate based on the questions we're asking it. That's an important distinction. So with that, we have our first iteration. We pick the best model out of 5, then we do it again, then we do it again, then we do it again, and we do it again. Now we can keep doing this as long as we want to pay for the process to continue. Or we decide when we're going to shut it down. What's important to recognize right now is that the final version of the model is not the same as the initial version of the model. The model has in fact changed. Either the data underlying the model has changed, the parameters have changed, or both. It is a slightly different model than it was before. It's doing this all potentially in real time, sometimes in minutes, sometimes in days, sometimes in weeks, depending on the model that's being used of those 10 that we looked at before. So a couple of things. What are the practical implications for us today as we start to absorb what this information means? That we can have a self-learning, self-adapting, self-referencing AI that's getting better almost on a daily or minute-by-minute basis. So a couple challenges that we're going to have to deal with right now. One is this is costly. You can think of building one AI model and what that looks like and running the model on a token basis. If I'm going to do this and replicate the model and then turn around and say I'm going to run 5 or 10 or 15 or 20 and I'm going to do that a bunch of times, I'm going to pay for that. It is not going to be cheap to have a self-learning AI in your ecosystem. It is also subject to what we call catastrophic forgetting. Catastrophic forgetting really means because the model has shifted and it is a different model the more iterations I go through, it will forget what you trained it on in the beginning. It has been fine-tuned throughout that process to the question and answer pairs that the evaluator is using. So it will forget what it did in the beginning. That's important to you. The next one is, it's not always provably beneficial. Just because we've optimized for a question and answer pair set, and then we put it into production, doesn't necessarily mean that model is better. It just means it's more accurate to that potential question and answer, that test we gave it. There's generational implications to this. So if we run this and say, okay, you run 5, 10, 15 iterations, generations out, but there's a problem with generation 1 and you let this model continue to go, by generation 5, 6, 7, 8, 10, 80, we may have amplified the risks or the mistake that happened in generation 1. So we have to pay attention to that. Optimization of the metrics. So a lot of people are already talking about, yes, we can optimize, we can make these things more efficient overall, we can make them more accurate overall based on the evaluation. However, what if it's not as safe as it was before? What if I've inherited biases in the data set because we've changed the data set? Keep that in mind. So the optimization metrics and how we're going to have to use that, have to think about which questions and which answers we want to have the evaluator use, now becomes more important. Are we going to allow it to self-reference or are we going to use a second AI? Those are two different risk profiles. If we're going to allow it to self-reference, meaning it's just referencing itself, likely higher risk than leveraging a second AI on top of it. And then the last one is, if you're going to use these agents, use these AIs, are there unmodifiable parts of the model? So you do not allow those to go through this iterative generational process. That would be your safety security type of features. So a couple more things. When and where would we even use this in our own environments? We're building out agents. We've got lots of AIs here within the firm. We have at least 11 times more AIs than we have people in the firm right now. Like, this is becoming quite normal. When would I actually want to leverage one of these learning modules or a plugin that says, I want this to start learning, this AI, this agent, whatever it might be in my ecosystem? There's a cost associated with that. So think through that process. When would I actually use this? One, potentially on initial development. So we have the pre-training process going on. Think of that as spring training if you're talking about football, athletes, and so forth, different sports. And then I'm going to actually level this thing up. I'm going to give it an energy drink. I'm going to actually let it do a little bit more by going through this generational process. Think of that as spring training or preseason, right before I go into full production. So initial development, I may actually leverage the pre-training process and then level it up using this type of self-learning. The next one would be is toggling this on and off. I don't likely want this to be on all of the time. You just think of what the cost of that would look like. It doesn't even make sense in many cases. The second one is scheduling these updates. So think of it as a mechanic in your car. Every once in a while, I'm going to turn this on and I'm going to allow it to go through a handful of iterations to improve itself. That's an oil change, that's rotating your tires. Like, that's just part of the process we're going to go through. If the AI that I'm currently using, the AI that's currently in production for me, if it falls outside of the normal parameters, expected parameters, do I then turn around and say, okay, I'm going to actually go through this process and level it up? I'm going to make it a bit more accurate. If new data is discovered, now this is an interesting one. This is a challenge for a lot of the static sort of frozen models. Think of from a legal perspective, we have new case law that comes in. Think of from a healthcare perspective, new research that comes in. I'd likely want to add that to the data set and then have it learn again. Version control is likely to become more and more important to you. So you think of how many times I'm replicating this over. If I find out that the system is not operating the way I expect it to or would want it to, do I revert back to an earlier version? It makes a lot of sense to be able to do so, but then how many versions am I going to have stored in my ecosystem? Because I'm going to have to pay for that. And so thinking about how I'm going to have to deal with version control, thinking every time I go through a self-learning process, I'm probably going 5, 6, 7, 8, 10, as I mentioned before, 80 generations away from the original model that I started with in this learning process. The last one here I think is really interesting, because this becomes part of the process that we have to talk about, the Frankenstein effect and others. Certainly with the people that are around us that are asking us questions, aren't you concerned about this? And maybe you are, maybe you aren't. But it is something to think through. There is what's called when we talk about authorization or AI paradox or automation paradox. The more we use the systems, the more we're going to have to pay attention to who authorizes those systems to be put into use. So within your organizations right now, if you're going to go through a learning process with your AI, using one of these potential options, a plugin, or it's embedded within the system, you're going to toggle it on, who actually authorizes the final version to go out into full production, into your environment? And is it one person? Is it 2 people? Is it 3 people? Is it 10? What is it? How many people are you going to have sign on the dotted line saying, I approve this model to go into production? What you're likely to see overall, and certainly here at the firm, we're talking about this on a regular basis, is it's going to be more than one person. It's likely to be a team that has to start to think through, are we okay with this model based on what it was on the Q&A pair, what it was trained on, what it was optimized on? And is that okay for us to go into full production? So there are a lot of things to consider. The news broke. We now have the ability on a research basis to start having these systems self-improve. That is, for argument's sake right now, it is being considered to be true. These are all journal, they have not been peer reviewed, the journal articles overall. So we can't say that everybody has said yes to the science behind it, but these are all pretty significant institutions that are behind the research overall. Highly likely that this functionality is going to be brought into commercialized spaces here in the next certainly few months, that these systems will start to be able to learn more and more, and you'll see more of the breaking news each day coming out about this.